Alrighty, so as I was saying before I started recording, we're going to be looking at the horizontal component of force. So after this, you're going to be able to calculate the horizontal component and use it in an F equals ma situation. So really what I'm doing is I'm taking those word problems that we've been doing and adding another step. Okay? Just like learning a new skill. Just kind of adding on. You know, you got good at that. Now we're just going to make it challenge a little bit. We're going to put 5 more pounds on that bar. Cool. Huh? What can you do?
Gotta go back and rework that lower weight to get up to the big.
There you go. Yeah, but I can't wait for you to put on that weight.
You gotta put in time.
Yeah, got to run the miles, man. All right. So here's a diagram you're gonna get to see. Now I should tell you right off the hop that this FH is kind of Bennett's old way of talking about it. Okay, FH stands for horizontal component, and I realized about a year or so ago that kids were confusing the applied force, the FA, and the FH. They thought there were 2 different forces. So now I'm getting rid of that, and I'm calling it FAX, which means the applied force X component. So it's the X part of the FA. Does that kind of make sense?
Oh, yeah.
It's the portion of the force
that is
making it go sideways. It's kind of like, I guess, a cheeseburger. You know, the FAX is kind of like the cheese. It's part of the cheeseburger. It's not a different meal. No, it's just a part of it. Did it make it more confusing? I'm sorry if I made that confusing. What I am saying, though, is that when you look at solutions, because I haven't gone back and changed every single answer to say FAX, I've changed them. They still say FH. So I just want you to know that FH and FAX are the same thing on the solution, and at some point, maybe when I get some free time, like after I retire, I'll go back and change them. Yeah. Fax. Do people still use fax machines?
Yeah.
I'm surprised you guys even know what a fax machine is, actually.
What?
Yeah? 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 Well, there's a fact I didn't learn today. Or I did learn today. I didn't know. All right, so, again, let me just read this. Let me go through it, and then if you choose to write it down, you can. So in a situation like this, not all of the applied force goes into accelerating the object horizontally. Right? So if I've got my little cart thingy here, right? Good thing it's called a crash cart. That's what they're called. It hurt your ears? It hurt your heart? It hurt my heart. Really?
Right on the heels.
I've dropped those countless times. They're pretty. The first time I did it, I was worried. Oh, no? They are. They are really good. And why can't I find the end of this? I had a student once, sir. I don't remember. So yes, the idea is that not all of the force goes into sideways. Only the horizontal component, and that horizontal component is this FAX. And again, FAX stands for the X component of the applied force. And it's a part of that FA. It's not a new force. It's a part of it. Only the horizontal component acts horizontally and contributes to the acceleration. And I haven't told you yet what the other component is. But you know what? Because you guys seem to be a little bit ahead of things here.
FAY?
You not only are you ahead, you didn't even let me ask the question. FAY. It's the Y component. Now, be aware that on old solutions, I've got that. If this is FH, what would I have called this one before? FV, yeah. That's what I called it before. But then again, I realized that kids thinking it was a new force, right? It's not. It's a component. X and Y components. The value of FH or FAX is dependent upon the applied force and the angle, right? The greater the angle, would it be the more the FAX or the less the FAX, the greater the angle?
Less.
The less, right? The steeper you go up, the less goes sideways.
Yeah.
I'll pause for a second. All right, so everyone's good? The FAX is dependent upon the applied force and the angle. In fact, I said this, but maybe we should just jot it in here. Bigger angle means less force. Bigger angle, less force. Right? Okay, now, how do I find out, like, if the FA is 100, how do I find out the value of FAX?
Oh, you.
I guess with the angle, maybe.
Okay? Okay. Well, here it is here, right? You don't need to redraw the picture, obviously. I just needed it on this slide so I could refer to it, right? Suppose FA is 100 and the angle is 30 degrees above the horizontal.
Wow.
Okay? Is that a 90-degree angle?
Yeah.
Will it always be a 90-degree angle?
No. Yes, it will.
Johnny says yes. Yes? How come, AJ?
Because it's just however along the horizontal line. A certain point of the
It's always going to be horizontal.
Okay. I mean, is it not just because horizontal and vertical are always 90 degrees? I mean, that's what it means, right? Horizontal means straight, flat, and vertical means straight up and down, and that means 90 degrees. So yes, this will always be 90 degrees, which means you can always use
Oh, no, not that.
sine, cos, and tan, right? Depending on which one you've got, exactly. So the FA would be, if this is the angle right here, and maybe you should do this, because I know that there's some kids that struggle with this. If that is the angle, the FA is going to be the adjacent, opposite, or hypotenuse. Hypotenuse. And the one over here is going to be the, and you can't see when I say over here, so that's, this is the opposite, right? And this one is going to be the adjacent. And which one, sine, cos, or tan, has adjacent in it?
Wow.
Cosine. It's not just what your mom does when you go buy a car, get a car loan.
Wow.
Not many people.
No, not many people will. Only a fraction. Right? So in this triangle here, cosine 30 is equal to adjacent over hypotenuse, and the adjacent is the FAX, and the hypotenuse is the 100, right? So now you have to solve this little equation right here. And how do you solve it when the unknown is on the top? Like, what do I do?
Oh, you.
I'm going to put that over there. You got to multiply, right? No, I don't want to get the Brazilians all riled up. But
What?
I'll say it in English so they don't understand what I'm saying. We're going to multiply both sides by 100. We were talking yesterday. They don't like me doing this. Multiply by 100 both sides.
Waste of time.
Don't encourage the Canadians to do that. So we're going to get FAX is 100 cos 30. Okay? Yes, because how many times have you picked up a pen and run out of ink because you've used it so much?
Never.
Never. Yeah, exactly.
Once or twice.
Most of the time you lose it before it runs out. So FAX is going to be 86.6. So 86, 87 newtons of force actually goes into going sideways. Okay? Yeah? If you need the other one, the other one, if you want, if you're looking for FAY, and I'm going ahead of the game here. No, I haven't got there yet. I just was taking a chance to hand them out. If you're looking at FAY, it's going to be 100 sine 30, isn't it? Right? But we'll get there yet. Was it? No, it's not number one. No. I'll just hand these out.
It's a question.
Yeah.
You're always going to be given it that much.
You're gonna be given one angle and one side.
Yeah. You got to be given one side and an angle.
Or you can get like
I could give you two sides, and then you got to figure the angle. That's true. Yep.
Yeah.
You'll always know that's 90 degrees. That's true. I guess technically two angles. If you want.
Wait, are we going to use both side law and side law?
No.
Oh, yeah, we can go this way.
So now if the angle increases to say 60 degrees, then the FH will of course decrease, which is what we've talked about already. But if you were to actually figure it out, right, if this is 60 now, Cosine 60 would be 100. Cosine 60 it'd be 50. There's the mathematical proof that it goes from 86 goes down to 50, right?
Yep, okay.
I think the next thing is example 1. Yes, it is. Okay, so those of you following along at home, you're going to go to example number 1.
Brett, what's the point of editing it? He does that when he comes to his phone. That's editing.
That's fine.
They want to put in like a little musical backtrack.
Music and stuff.
Yeah, some backbeat or something, right?
We don't have time.
We need some subscribers here, son.
I'm going to start you off easy. A force of 100 newtons is applied at an angle of 30 degrees above the horizontal to a 25 kilogram sled. Determine the acceleration if the surface is frictionless. Let's start by drawing a free body diagram. So there's our sled,
60 decibels.
right? And we've got a force of 100 newtons at an angle. So that's a 100. The angle is 30 degrees. Oh, didn't we already figure out what these values are? Right? And the surface is frictionless. So all we also know is that it's 25 kilograms, right?
We don't actually we ever use a voice actor? No, we never have to. Wait, I guess because it's all in your mind. It's not
Wow.
but like,
Oh, yeah.
It's just a visual.
Yeah, just a bit. Oh, are you asking me if you have to draw that exactly 30 degrees? No, just a sketch. Just a sketch. Okay, so first step, find the FAX. Find the x component. Our new now I haven't really come out and showed you this, but the formula is FAX is equal to FA cos theta. Is it always going to be that? Is FAX always going to be FA cos theta?
Yeah.
It is the FAX always going to be the adjacent one?
Oh, no. Yeah. Yeah.
Well, 99% of the time. Because on the rare occasion, if the angle is really steep, sometimes they give you the angle from the vertical. But as long as it's 30 degrees above the horizontal, then yeah, it's going to be cosine.
But then it would still be cosine.
No, because then it would be like this. It'd be, and this here would be, right?
Oh, yeah.
But 99% of the time, don't worry about it. So in other words, FAX is FA cos theta. Okay? So we got our 100 cos 30, and I think we've already worked that out, have we not?
3,
Yeah, 86.6.
Cos of 30.
Okay?
For 3.
Now, I should also point out, and Johnny, you need to pay extra close attention, given all the time you missed here, right? I should also point out that there is a weight force and a normal force here, right? But they are equal and opposite, so do they have any effect on things?
no.
Not yet. Not yet. They will once friction gets involved. Okay? But I'm going to slow your work into that. So this is frictionless, so we don't need to worry about those. So in other words, the FAX is really my F net. Right? Because the net force is simply the sum of all the forces. There are no other forces to add.
What if there was?
Then we're going to have to add them. We're going to have to insert that step there.
Like the,
I think the next problem shows that, Leo. Okay, so hold that thought. Okay, so now we're going to go F net is equal to MA. These, no, they're the same. That's what I was just saying. They're equal because there are no other forces.
Why are you writing that down? Why don't you just keep it as FAX?
Because when I go over here to F net equals MA, some people don't like the fact that it's not the F net.
Are we doing an example when it's going?
Oh yeah, I'm going to do it right away.
So we're finding acceleration.
Saying I really don't. Acceleration is a vector quantity, which means that it has a direction. But is there any direction mentioned in the question?
No.
No. Which kind of means
That's it.
we don't need to. In fact, the fact that it's positive is good enough for our direction.
Yep.
Okay?
So do we have to?
Man, you
make
could
it
get like-
positive, or you can treat it if it's not?
Yeah. I don't need it to have. Just 3.46 would be fine
Okay.
in a situation like this.
You could get like a 10 step away from it.
Oh, yeah.
You could get
Please don't.
like what could come after this? I could ask you like how fast it's going or how far it goes. Yeah. I'm gonna build, right? Slow. It's gonna build slow. Okay. So this time, do you want to try this one?
Wait, Mr. Bennett, go back to 2 seconds.
Oh yeah.
Sorry. You know what?
All right. So example number 2.
Shaking my head.
Example, yeah, frowny face is right. Severe frowny.
That's a bigger frowny face.
That is a frowny face.
Can I slap it once?
Wait till later.
Well, actually, you're in a pinch trick, so.
Actually, I should jump.
A force of 50 newtons is applied at an angle of 15 degrees above the horizontal to a sled having a mass of 30 kilograms. If the friction force is 5 newtons, determine the acceleration of the sled. So the only thing different in this one is friction. So let's draw our picture again. Let's have some practice at it. 50 newtons. The angle is 15. Okay, tie. Chill, man. So now I've got this little friction force right there. Now, why is it backwards? Why is it to the left like that? We tend to assume if there's nothing given in the question that it's automatically moving to the right. It's just the way we live, right? So we're going to assume the friction force is to the left. So same steps. FAX is equal to FA cos theta. Theta.
Cool.
50 cos 15. How do you say theta in Portuguese? Thank you. Which is not surprising given that it's a Greek letter.
He's like, because you guys say theta,
Yeah?
and theta in Portuguese is tits.
Oh, easy.
Straight up. No censorship.
Well, I guess that I got to be careful then, eh?
Yeah.
Theta.
Okay. Yeah, I get it now. All right, 50 cos 15 is 48.3. How come it's so close to 50? How come it's 48.3? Why is it so close to 50? Because it's a really tiny angle, yeah. Most of it is sideways. Here's the step that we didn't do last time. Now I've got FAX, which is going sideways, and I got FF, which is going backwards sideways. So now, because on the last one I just said the FAX and the FNet were the same, but now I have to go FNet is equal to FA plus FF. Oh, it's not FA, it's FAX, isn't it? Right? Same thing, yeah. The FNet is the FAX plus the FF. Mika, are you staying with me here? Okay. And that FAX is 48.3. And the FF is, now let's write it as plus minus 5.
I love writing out like that, so I really prefer it.
I would prefer you write it that way, which means that our net force is reduced down to 43.3.
I think it's 43.9, no? 48.9. Or 48.
What?
No, 48.9 instead of 40.
I got 48.29.
Same here.
You guys round weird in Brazil. That is equal to FA. So 43.3, the mass is 30. Divide both sides by 30. No problem, Leo.
It's probably the way to calculator.
Yeah, maybe you just punched it in a smidge wrong. I get 1.44 meters per second squared. So really, what extra did I do?
Just the friction.
Literally what we did with last year.
Yeah, exactly. Just adding. I'm just adding bits to the cabin we're building here, right? No, it was a metaphorical cabin.
Almost exactly.
Well,
We're done with it, so.
We're building the other class with Shed because Mr. Sheldon was interested in
Where is your bed?
Oh, Leo, what are you doing? Alrighty, a man is pulling his 50-kilogram stud. That's a big kid. On a 15-kilogram sled across an ice surface with a friction force of 2 newtons, the rope makes a 30-degree angle with the horizontal, and he applies the 250 newton force on the rope for 3 seconds. Find the final velocity of the sled and the distance it travels for 3 seconds.
I think that.
I hope you have a full page to write with. Yes, you do.
I think that kid could stand before. What? That kid could stand before the dad.
250 newtons,
It's one big kid.
30 degrees.
We don't know what age is it.
No, we don't. Friction is only 2.
Oh, that's not very happy.
No, it's ice, right? We need to find the final velocity of the sled and the distance to travel. So we're going to have to do all of this, and then once we get the acceleration, we're going to have to do that some velocity stuff, right? Okay, so you should definitely be able to do the first part, and you should be able to do the second part as well, really. You've done it before. So FAX is going to be FA cos Greek letter
I hate
theta
Greek letter.
heads.
250 cos 30 216.5. Is that number always going to be less than the FA?
Should.
Yeah.
The final velocity is 0, right?
Unless it's
The initial.
The initial 0, right?
Unless it's 0.
Okay, so now we got our FAX, and some of you might be working ahead already. F net is equal to the FAX plus the FF. Yeah. I'm just being complete. 216.5, and we're going to add -2, which of course is 214.5. Now what?
Acceleration.
Find the acceleration with F net is equal to MA. 214.5. Now, I got 2 masses here.
Well, you add them together.
Add them together? How come? Yeah, I'd say same thing, right? Do I need to show that work? I think we can all do 50 plus 15 in our head. I really hope so. Although I've seen kids multiply by 1 on a calculator, so
So they're just double check.
I guess, yeah.
Kidding.
Sometimes you need to double check. I've done it before.
Divide both sides by 65. 3.3.
Gotta make sure.
So that's really what we've done up to now, and now we're going to go back in time a little bit, and now I got to find the final velocity. Leo was already thinking ahead. The initial velocity was 0, right? So like A is like delta V over delta T. This is from the last unit.
Yeah, but this kid's getting pulled. 110-pound kid.
It might be a little fictional
Or friction.
or frictional. You know?
Frictional. Say.
You guys are spending way too much time with me. Starting to wear off.
That's great.
Thanks. No glasses today there, Dawson?
Could you tell?
Did you multiply both sides by 3?
I did. Now the initial velocity is 0, so therefore the final velocity is 9.9, right?
Yeah.
And how far does it go in 3 seconds? Here's the most common mistake, the one that like I go, oh, I can't believe they did all that right and then made that mistake. How do we find distance? What formula?
Distance is delta D over delta T.
You use distance to find
You're
distance.
rolling away.
You're close. Isn't it V bar? V bar, right, is D over T. Do we have the V bar?
Yeah,
No.
you can find.
We can find V bar is VI plus VF over 2. We've got to find the average.
Why?
Because down here I'm going to write V bar equals D over T. And this is not V bar, this is VS. That's the final, right? The guy starts pulling at 0. When he's done, he's pulling at 9.9. But what's the average? Well, that's going to be 9.9 divided by 2, isn't it?
40.7.
4.95. Away here, right? So it's going to be like,
You should say, very good job.
yeah, good. Well, if you get it right. So that's 4.95 D over 3. Multiply both sides by 3, and what do you get? Like 14.85.
Let's go.
Well done if you got it right. Now, of course, the follow-up question is, well, there's two questions. Will it ever be on the test? And B, how much does it work? And the answer to that is yes, and let's find out. One,
But then check the, would you find out more than that?
I had to find the final velocity, which I did. So 1, 2, 3, 4, 5, 6.
That's a picture. But no marks for the final velocity.
Well, that was part of it. Yeah, when you got it here. That's kind of the one and the same. Oh, yeah. Now, is that more than you've been doing? Absolutely, right? You got to lift the weights, run the miles. You got to practice.